Multiplying fractions in algebra is, you guessed it, just like multiplying fractions in arithmetic. If I start with the example 8 over 9 times 3 over 10, I know that some of you just multiply across and then simplify, but because it mirrors more closely what we'll be doing in algebra, I would like you to think about 8 over 9 as like factor the 8, 2 times 4, and factor the 9, 3 times 3, and then multiply that by 3 over 2 times 5. If I extend this whole bar, since we're multiplying everything, we can do this. I can see that I've got a 2 that cancels with this 2. I've got a 3 that cancels with this 3. And then when I multiply across, I have 4/15. If you were doing this in elementary school, you would have made this 4, this 5, this 3, this 1, and as you can see, that's exactly what we did, 4 out of 15. So this leads us to the basic procedure that we will be doing as we multiply algebraic fraction. The first thing, and you'll see this is a common theme this chapter, is factor the numerators and denominators. Second, cancel common factors. And third, multiply across. So let's see what that looks like without. Here's a simple one because there are no polynomials, it's all monomials. 6x times y to the, over y to the third times y squared over 15. I suppose you could think of this as 6 times x over y times y times y times y times y over 15, and you can see the 3's cancel here, and these two y's cancel here. And so from this you can see you have 2x over 5y. I think it's easier, though, if you look over here, to do that same basic thing. But just know, like when we were dividing fractions, if I've got y to the second on the top and y to the third on the bottom, it's going to cancel out and leave a y. Then all that's left to do is multiply straight across, and you can see that the answer is 2x over 5y. I'm going to start a new screen here. When we get to having polynomial numerators and denominators, the whole thing takes more space. So in the case of x squared minus x minus 12 over x squared minus 5x times x squared minus 25 over x plus 3. Now, first of all, just as before, put your polynomials in parentheses. Do not get tempted to cancel parts of these things. Instead, we first need to factor. And hopefully you can do this without any review. To factor the numerator on the left, it's x and x. My signs are different. I'm looking for numbers that multiply to 12 and subtract to 1. They are 4 and 3, and the 4 goes with the sign of the greater because when I combined them, it turned out negative. X squared minus 5x, all that is to be done is to factor out the common factor of x. X squared minus 25, though, is a difference of squares. So we know that we can factor that as such, and x plus 3. So the factoring is done. Now it's time to go across and cancel out common factors. X plus 3 cancels out with x plus 3. And notice, this is one thing that's important. I don't want to take this for granted. You can only cancel something on the top with something on the bottom because it, after all, is based on the idea that any number divided by itself equals 1. X plus 3 here divided by this x plus 3, they have to be on the top and the bottom, equals 1, hence they cancel out. X minus 5 divided by x minus 5 equals 1, so they cancel out. Now all that's left to do is multiply straight across, and you can leave your answers in factored form. But don't be tricked into thinking that you can cancel this out. You can't. You can only cancel things out if the entire polynomial is the same on the top and on the bottom. Another thing that comes up in this section is the notion of something like x over 3 to the third power. Well, we know anything that's raised to the third power means you're multiplying it by itself 3 times. And to multiply fractions, we multiply straight across. That becomes x to the third, and straight across, 27. So you can see from this example that the shortcut is to raise the numerator to this power and then the denominator to this power. X to the third over 3 to the third is 27. If I extend that, I can also do problems like the opposite of c over 2 squared times 4 over 3c. A negative number raised to an even power is positive, so we know that this is going to give us a positive number. And c squared, to the second power, is c squared, and 2 to the second power is 4. I'm going to multiply that by 4 over 3c. Clearly those cancel out. There are 2 c's here and 1 here. One of them cancels out, leaving this with a c. So I multiply straight over across, and I get c over 3. So basically, if you follow the same cautionary things as we talked about yesterday, put your polynomials in parentheses, cancel only once something is completely factored, and then multiply straight across, you should have no trouble with this.